Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
I guess I'm supposed to start talking now. So, good morning. Welcome to the DPC hangover slot. Just before we get started, does anyone here need me to speak quietly? Maybe dim the lights? Anything? Okay, pretty good. Pretty good. All right. I'm glad to hear that because we're going to look at a lot of code today. A lot of code. All right, so who am I? In case you didn't see yesterday, my name is Ross Tuck. I'm team lead at iBuildings Utrecht. That also makes me senior developer, API specialist occasionally, headgear consultant, diversity hire. I'm not Dutch. Some of you are. I won't hold it against you if you don't hold it against me. Okay. You can find me on Freenode, Twitter, etc. as @RossTuck. On Twitter, I also have my own hashtag, Dashingly Handsome. Okay. So, quick but necessary review. How many of you guys here have used Doctrine 2 before? Cool. How many of you have never used Doctrine 2 before? It's a little tricky for you. All right, I'll try and give you the Cliff's Notes. All right, I'm assuming most of you had Doctrine 101. Some of you guys haven't. So this is kind of Doctrine 102, maybe Doctrine 102.5. I'm not going to show you how to build SQL walkers, but I won't show you how to map your DBs. So, okay, somewhere in there. If you haven't worked with Doctrine 2 before, it's a data mapper, not an active record. You map your models. They have no base class with just some nice simple annotations to describe what they are. And then you can use an entity manager in order to set these to the database. So you just find one particular piece of something, an article in this case. You find it by class name, and then you set something to it, and then you flush it with the entity manager. And that concept is really important. If I had fetched two articles and changed them both, then flush would push them both to the database. It's not like there's an explicit save function or something, okay? This is a source of a lot of power here, and we'll talk into how you can tap into some of that today, okay? I want to talk about filters, but before I do that real quick, how many of you guys have ever worked with somebody who is really sneaky, like really quiet, could come up behind you all the time like a ninja? Yeah, a couple of you. Exactly. I had a system administrator who could do that. He was really good. The worst thing would probably be a boss who can sneak up on you and do that. He's just like there, suddenly, working, and he wants something from you. In this case, he wants to give us a change request. He says, we need a way to approve comments before they appear to all users. Now, if we look at our controller code, we can pretty quickly see what our boss, Doug Manatee, is upset about. If you run this code, you'll see two comments here, one of which is clearly going to be approved and one which is not. All right, so now you look at this, you say this is actually a pretty simple fix. All I'm going to do is change the find all function to something like get only approved functions, yes or no, get approved comments, etc. But you might have somewhere else in your code where you're doing it with a DQL query. You have to modify that. Maybe I'm using the automatic association stuff, and you can't even attach a filter to that really easily. So you're going to have to change this in like 100 places in your code maybe. That's not cool. All right. So a better way to do this might be a filter. These are pretty new pieces of something that were added in Doctrine 2.2. They haven't really been used as much as I think they should. They're neat. They're pretty easy to build. All right. You extend an SQL filter in class, and then you can simply implement one abstract function, add filter constraint. It just gives you two parameters, all right, entity info and an alias. I'll talk about how you use these. Entity info is just an instance of class metadata or class metadata info. I'll talk about that a little later on in the presentation, what you can do with it. But in this case, the name is just the class name. Now, a filter gets run for every single model that you fetch from the database. So we need to filter out the ones that we don't want it to filter for us. Does that make sense? So in this case, we just say if it's not a comment, then we're going to return an empty string. That's all we want it to do. Now, if it is something we want to filter on, say a comment, then we're going to return an SQL snippet. That's SQL, not DQL. All right. In this case, we're just going to check if the approved flag is equal to 1. Pretty simple stuff, actually. Now, the alias. Why am I using the alias here? If you've ever looked at the SQL that Doctrine outputs, it will sometimes rename your tables to things like P01, P02, something like that. The alias that it's going to use for the SQL statement is what's passed in here. You have no way of knowing what this is going to be beforehand, but odds are it's not the table name you think it's going to be. So always, always use the alias as part of your SQL snippet, okay? And everything will go okay, all right? Now, it's not enough to just build the filter class. You also need to register it in your Bootstrap, okay? So you need to add a filter, and this is a little different than you might expect with many things in Doctrine, where instead of an instance, you're going to give it a class name, a complete class name of whatever your filter is. Okay, and you also need to give it a handy key because you could be assigning the same thing more than once for some reason. All right, and it's not enough to just do that. You also need to enable the filter by the handy-dandy key. All right, at this point, we're pretty much done, except for we just need to check to see, hey, is this a normal user? And if it is, we're going to add the filter onto here. Okay. Now, if we go back to our controller, you can see it's a controller. I've annotated all these nice and neat for you. Then you can easily see that if we run this as a normal user, we only see the approved comments. Right? If we run this as the admin, then we're going to see all the comments. Pretty easy. Let's just hope employee ID is not attached to the comments. Right? And now you can also do parameters with filters. They're pretty cool. You can just simply get the filter you want by the handy-dandy key, and then you can set a parameter on it, a user level. Maybe we have different levels of approval for comments. Managers love that stuff. And then all we have to do is modify our SQL filter class so that we get the parameter from inside of it here, and then we put it in our SQL statement. All right? Not too hard, I think. Now, there's one little gotcha here. It's not even a big one. The get parameter is already going to be escaped. Okay? It's going to be escaped for your SQL stuff, so you can just plug it straight in there. The only way this can really bite you, though, is if you're not expecting it, and maybe you do a comparison on what you set and then what you get, because they may not be the same. In fact, odds are they won't be. They'll be quoted at that point. So they won't be equal anymore. Okay? So that's the way filters work, basically. There are a few limitations about them. They don't work for update or delete statements in DQL. All right, so they're just not applied. That's not really a big one. And obviously, if you're writing your own SQL queries and executing them through the DB connection, then Doctrine has nothing to do with that, and the filter will not be applied. This also applies if you're using the native query mapping that Doctrine provides. All right? Are you guys awake? Okay, cool. All right. Now I want to talk about events next up. Events are, in my mind, one of the killer features of Doctrine 2. They're really, really cool, and they use them for a lot of different things where maybe other ORMs or other libraries would use, say, decorators or something like that. Come on in. Okay. Anyways, they're really, really cool stuff. I just want to dive into using them a little bit here real quick. This is a list of all the events I could find in Doctrine 2. All right? Now, on the left side of the screen, you'll see stuff that looks pretty familiar. My simple CRUD operations, pre and post on them. If I can make a gross oversimplification, persist is kind of like insert. So that might make it a little more familiar to you. And this is the complete list of what you got here. All right? Now, there's two ways you can hook into these. You've got callbacks and you've got listeners. And the simple difference here is that callbacks are on the model and listeners are external objects. Okay? I'll show you how they work with callbacks. That's easier. All right? Now, for callbacks, we just have our simple article entity, like I showed you earlier today, and we simply have our controller, same as what we did before. Okay, so Doug is back. He has a new change request for us. In manager style, he wants to know the last date any of the articles were modified. Okay, again, this looks like a simple fix if you don't consider the size of our code base, because we could just simply say set updated at, and then record the new date time, and we're done. Cool. You just got to do this on 100 other files now, wherever you're using it, and test them. And you're going to miss some, so you're going to get bug reports, and Doug's going to get mad about that. So you can have fun there. I would argue a better way to do it might be to just leave your controller exactly as it was and not change anything here. Instead, we can go to our model and we can change it to fix this problem. We're going to use an updated at attribute, just like I showed you. And we're going to add a couple things. First off, a function, mark as updated. And it does exactly what we were just doing in our controller. Okay, you say, this is not much of an improvement. But then we're going to add two annotations, has lifecycle callbacks and pre-update. All right. Now, these are event mapping. The has lifecycle callbacks is simply an opt-in way to say, hey, look, our model has events. Doctrine, you need to start paying attention to them. And the pre-update says, whenever we're about to update something, then just run mark as updated. Run it for us. Make sure it always happens. And that way, our controller never needs to change. This will exactly work. If we take the flush now and we echo the updated at after we've pushed everything to the database, then we're going to get the timestamp for, 2 minutes in the past. Darn. Okay? So that's basically it. We're done. We've fixed it. It's all over the place in all our 100 files because we didn't have to make any changes to our controller code. Yeah, cool. Just added this. So what else can I do? Now, with lifecycle callbacks, you have these are the total list of options, and these are the ones you can use by specifying an annotation. So most of them, they're pretty much there. It's pretty cool stuff. Now, a quick pro tip, if you're going to start trying this code out, This only fires if you're dirty. And I don't mean your new mud wrestling class, okay? It simply means that if I run this right here in one request and I get my timestamp out, then there's a timestamp. But if I run this exact same request a second time, I get the same timestamp. Right? Why is that? Well, Doctrine is a little bit smarter than we are. It says awesome new story is, well, the same as awesome new story. Ergo, there is no update, therefore I'm not going to push anything to the database and my callbacks are never going to run. Okay? This is not something you're going to see too much in live, but if you change it to fantabulous updated story, now it works. Okay? So this is something to watch out for during development more so than anything. So you may want to just do something really stupid like this when you're developing your listeners. Just plug in something, slap a new ID at the end every time. All right, this will make your life a little bit easier. So here's the thing. Events are really, really cool. I like them a lot. They're one of the killer features, like I said. But callbacks as an implementation of events, okay. Right. Okay, they have some issues, and they're really good, don't get me wrong, use them, but they're limited in model dependencies, and this is one of the main problems. If I want to mail something, for instance, I cannot do that here. I'm not going to put Zen Mail or Swift Mailer inside my model. It doesn't belong there. So I can't trigger anything else except for changing a few fields. And also, in order to change that field, we had to add a public function. Now we're tampering with our model API to help Doctrine, and the model API is the most valuable thing we have. And now we're making compromises on it. So now you say, okay, well, I'll make it a protected function. But if you do that, Doctrine will simply not register it as a lifecycle callback. It will just skip it. And there's no warning, there's no error about it. You just won't realize that your junior changed it to protected function. And, oh, great, 6 months down the road, I don't have any updated at timestamps. Crap. Okay? Also, if you're doing things that are not repeated in your actual model base class for every single entity, you're probably going to end up with some duplicated code as you try and figure out the best way to get your lifecycle callbacks in every single model where you need them. All right? Inheritance is a little tricky here. Lastly, there are performance implications. The @has lifecycle callbacks annotation is there to opt in because, well, it can cost you. All right? That's not something you need to worry about right away. I think these other issues are bigger, but it's something to be aware of. So I would argue that listeners are actually a better way to go about this problem. All right? So listeners are really, really simple. They're an external class, like I said, and you just create a function there that's named after the event you want it to listen on. All right? Now, it's not enough, of course, to just create the class. You also need to register it. All right? So you need to give it an array of the events you want to listen on, what you want to fire on, and you need to give it an instance, a configured instance of that listener. Okay? So it's not too hard. You can also invert this logic and do, instead of add event listener, you can add event subscriber. And now I don't have to specify the stuff in the bootstrap. Instead, I'll do it inside my actual listener itself with this little get subscribed events function. All right. You also need to implement an interface for it. That seems like a lot of code because it's crammed all on one slide, but it's a one-line function and an interface. You won't really notice it. You say, why would I do that? Because functionally, these are exactly the same stuff. There's no difference. They work the same, okay? But design-wise, I would argue that there's a little bit of an improvement in doing a subscriber, because if I'm writing a handy-dandy listener and I farmed it out to a lot of people in a lot of projects, and then I realize later on I need to listen to another event or I need to do other stuff, then now I have to go ask them to change their bootstrap code too. And if they don't do it, it's not firing on every event. I'm going to get weird bugs and weird bug reports, blah, 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 blah. Had I just put it in the class with the subscriber, I just need to push the new class out and we're good. We're done. Okay. One of the other things I mentioned is that now, because I'm actually passing in a class, then I can also pass in dependencies. I can dependency and check my Swift Mail or my Zen Mail, whatever I need to do here. So that brings a lot of power with it. So in order to demonstrate how you work with with listeners, I'm going to show you how you're going to do that by redoing what we just did as a listener. Now, the trade-off here is that there is going to be some higher complexity. But if you bear with me, I think you'll see in the end it's worth it. Okay, first off, we say what events we want to subscribe to. Easy peasy. And we're going to add a pre-update function. All right. And I'm going to zoom in on the pre-update function. All right, first off, we get the event class, and the event we can get different pieces. Now, I'm going to stick to a common subset of what the events give you in these examples, but different events will sometimes give you different options, different functions you can call, access to different things. All right, so we're going to get the entity manager from our event, and we're going to get the model. You know, pre-update runs once for every model that's getting updated. All right, now, just like when we were doing with the filter, we need to make sure we're only operating on articles, okay? We don't want to try to set this stuff on comments and things like that. now we get to the actual nitty-gritty of it. We set our event here. We set our new update time. And now here's where things get a little weird. Okay, bear with me here. We need to get the unit to work. Now, anybody here familiar with the unit to work? Okay, yeah. In case you don't, it's like the shadowy power behind the throne. If you watch Game of Thrones, it's like the hand of the king. All right? So it works on different terms. It has different things. Entity Manager is in many ways just a facade to unit of work. And unit of work in its mind, I think, is really centered around the idea of change sets. It bundles up all the things that need to be inserted, updated, deleted, whatever, and it tracks what fields in those need to be changed. All right? So it's really, really oriented around change sets. And now that we're inside of this event, which is happening inside of a flush call, then we're on unit of work's terms. We're really doing what it wants by its rules, and we have to change how we work a little bit here. All right? So what we need to do is tell unit of work, hey, you thought you had your change set figured out, but now I'm up in your events, killing your dudes, and we need to tell it, you need to rethink your change set. You need to come up with a new change set to match what we're doing here. And that's why we're going to use the unit of work recompute single entity change set function. Cool, right. Now, that seems pretty scary, but if you understand it in the terms outlined, I think it's not too bad. It just needs two parameters, class metadata. I'll talk about that again, like I said, later on. It's just information about it. You just have to feed it this line, and then you need to give it the model itself so it can figure out the change set. If you do this, and close your parenthesis, then you're good to go, actually. This will do exactly what we needed to do in the previous one with the lifecycle callback. We don't have to change this. We can get the updated at feature again, and we can print it out. Now, by looking at your face, you're saying, whoop-de-doo, Ross. You took something that was really simple and you made it really complicated, and now I'm scared and I don't feel good and I want to go home. All right? Why would I possibly use this instead of a lifecycle callback, even with the performance implications? All right? Well, go with me on a trip to theory land. All right? Now, in theory land, we have an interface. Set updated at and get updated at. Very simple. Now, all we have to do is change our pre-update function in two ways. One, we're going to change the article here to a last updated interface. So now we're only working on things with this particular interface. Then we're going to change down here where it says get class metadata. We're going to get the class of the model itself. Okay? Now, if you stop and think about this for a sec, we don't have to build a listener per class anymore or anything like that. We can have a standard common interface that we stick on our models. Our class article implements last updated interface. Good to go. We could use this on 40 models, on 10 models, 100 models. It's going to work fine. Okay? Also, now we have a defined interface for the stuff that we can test against. We can mock it out. Okay? We couldn't do that so easily with the callbacks. Callbacks are good, but in my mind, this is just pure power. All right? You can really do a lot of amazing stuff with this by defining standard interfaces here. All right? This is the beauty of listeners, actually. So you're going to have to use some more complicated stuff. You can get into more things with it. It has more power. But you do the trade-off is that sometimes you have to call scary named functions like a recompute single entity change set. Okay? That's the joy of listeners. Now, moving on real quick, I want to talk about flushing and multiple events. On flush is one of my favorite events in Doctrine, and not just because of the obvious toilet humor. All right? Doug is back. He's got a new request here for us. And he says, after every update to an article, I want an email of the changes sent to me. All right? The timestamp isn't enough. This is a typical managery request. All right? Also bring me more lettuce. Damn manatees. All right? So we're going to build a change mail listener that's going to solve this problem everywhere in our application really easily. All right? First off, we're going to listen to two events this time, on flush and post flush. Now, on flush happens when you call flush. It's like the last thing before it starts writing to the database. And this is your chance to basically get away with anything. All right? Pre-update has certain restrictions. These are documented well in the manual about what you can and can't do. On flush has almost no restrictions. You can get away with a lot of stuff if you know how. All right? Post flush happens at the very end, after everything is written to the database, after the change sets have been worked through, and you're all good to go. Okay? So what we're going to do in our listener here is we're going to use a protected mail message to store state that we're going to use between the two events. All right? It's all within our class. Now, we're going to listen to the on-flush event here in order to build up the mail message. Okay, first off, we get the unit to work again. And I'm going to expose to you some of the cool stuff that unit to work can really, really do. You can get a list of every entity that's about to be updated in this current request, whatever that number is. I don't hear anybody saying cool. I think it's cool. But you can get anything. Even better than that, you can get a change set for every single one that's about to be updated. What is a change set? What does that look like? It's an array, and it simply tells me what things I've changed in this request with the old value and the new value per entity plus, if I would change content as well, that would appear underneath here. You can do this really, really easily. And I think you can see if you look at this code now exactly how easy it is going to be to fulfill Doug's request. All right. All we have to do is create a function which just formats this all pretty in a mail message for us. We pin that to this mail here, and we have that mail message. The only question is, should we send it here in onFlush? And my answer is probably no, we shouldn't. Because what happens if the database connection drops, our transaction fails, whatever, then Doug is going to get an email about changes that never got written to the database. Okay? So I would argue you should wait till the post-flush event after everything's been cleared and it's good, all things are fine, and then you just check, do we have a message to send? Was there anything to update? And if so, mail it to the boss. And you're done. Okay? So that's really all there is to it. Now, mailing the boss like this, like I said, this is a common request again. And honestly, if I had to hunt and peck through code, I could easily scope, like 2 days for this. Just running through everywhere and making sure that mail gets sent. Here, we can do it in about an hour. So I think that's pretty cool myself. If you're curious, by the way, what was in the format all pretty in mail function in my sample code, it's really dumb. It's not even that pretty. But this brings me to a good point here. I think it's a good point. Piece of advice. Treat your listeners like controllers. Now, we're doing a hell of a lot, actually, inside this listener now. We're formatting a template. We're sending a mail message. We're talking all sorts of things. I would say that you should treat your controllers and your listeners as the same level of abstraction here. In fact, if you're doing JavaScript MVC, this is probably what you're doing anyways. Your event listeners are controllers. Now, in PHP, that's a little bit of a newer concept, but the fact is that formatting your mail message doesn't belong here. It belongs in a template. You should be using Twig or something like that to render it and stick it in the mail body and go. You should just be calling, service objects and stuff here. All right? So keep your controllers thin. Therefore, keep your listeners thin. All right? It'll make it easier to test and mock. Also, once again, I showed you here about how you can use change sets, and I directly hard-coded article classes. But you could really just change that to an interface once again, and then just tag which models you want to email the boss about with just that interface. And now we can send him one mail with articles and comments, updates, stuff like that. So pretty cool, I think. I want to take you on a different route now to Crazy Town. I've showed you so far how you can read and add things to change sets. I want to tell you how you can actually put whole new stuff in change sets, which is good. Doug's back. Anybody tired of the manatee image yet? Nah, darn. All right. I want to write the change messages to the database instead of emailing him. He's drowning in these emails. All right. So we're going to put them there so we can search and sort on them. All right. So I'm going to create a new entity, Changelog. And this is very simple. In real life, you would put more information in here. But I'm just going to create a description and a primary key for it. We can search and sort it, whatever we want. All right. And now we're going to create a change logger. This is going to listen to only onFlush. We're back to one event. Easy peasy. And we're going to do get our ending manager unit of work. I guess you guys are familiar with this at this point. And we're going to get the list of all things that are ready to be updated. And we're just going to filter those again for article or whatever our hypothetical interface is. And now we're going to create that new change log. We're going to put the pretty message in it that we want to save. And here's where things may get a little controversial. You can do an entity manager persist on this new entity, and then we do compute change set instead of recompute single entity change set. That sounds a little weird, but this is a brand new entity. There's nothing to recompute. There is no change set for the entity. All right? So we just need to compute the change set. That's the difference. But it takes the exact same parameters as the last one. All right? And that's really all you have with this. Now, if you look at your database, yes, I did just use phpMyAdmin there. Then you can see that we've logged all these messages directly to the database. It's done. It's cool. It's happy. We're good. All right. Now, wow, pretty cool, actually. This is something, once again, where if you had to go hunt and peck this through your code, you could spend days on this. And once again, we're done pretty quick. The problem is that this, if you're not careful, this can turn into a real minefield. Events are a lot more complicated in some cases. I've danced completely around the issue of how do you handle IDs on insertions. Because if you want to add related entities, you don't have IDs in onFlush. So how am I supposed to join these things up? And I'll show you a couple solutions here real quick to that. But the quick answer is if you're doing this particular use case, I would highly recommend you take a look at the Doctrine extensions on GitHub. they've had a lot more code review than what we're showing up here, okay? And they're pretty handy stuff, but this is the principle under the hood of how they work. All right, now unit of work has a lot of other cool stuff going on under the hood for it. I've shown you that you can get updates and all over the place, but you can do deletions, insertions for actual models, but you can also get for relations, for things that are about to be inserted and added here, okay? Now, unit of work is a lower level API, and you can actually use these functions as well to simulate a lot of what I've shown you here. So you can schedule things for insert and update and stuff like that. Now, you'll probably see performance increase here because you're not doing quite as much work, but you're also going to potentially be safer if you know exactly what you're doing. I've been told that if you use persist in certain event contexts, that you can break your unit of work and the whole thing will go kablooey. I've never seen it, but it can happen apparently. So in those cases, you may need to switch over to schedule for insert. The downside is that this happens later on in the process. Persist actually calls schedule for insert at a certain point. But the things that you skip in that process are things like firing the pre-persist event, so on and so forth. Oh, and schedule for extra update. This is an interesting one here. This is used by the Doctrine extensions bundle to work on how do you fix that ID problem I hinted at. It schedules an extra update to take place after all the other insertions and updates have taken place. So at that point, you know what the ID is, and you can schedule that to be set at that point. I've also seen people work around it by tampering with the dependency calculator so that you can ensure that those things always happen way late in the game, but it's maybe a little bit scarier technique. Honestly, I'd like to provide you with more information about these. The fact of the matter is, these are not documented anywhere that I can find. And getting information about them on IRC is something that's proven a little tricky, actually. So, sorry. I'm hoping that they'll do something with documentation for these a little later on in the year. But there are many, many more functions on unit of work. You can do lots of really, really cool stuff with it, okay? So Doug is back again, and he says, this time, no, I'm missing a slide. That slide should say PostLoad. We're moving on to another event.
It's only a white. It's white. Yeah.
Oh, yeah. The white screen of death, ladies and gentlemen. You've seen it here for the first time. So we're moving on to PostLoad. This is a different event, and it's really, really cool, actually. Doug is back, and he says, so our database server is really slow. You say, why is it slow, Doug? I haven't changed anything. He says, yeah, well, you know that intern we got? Well, I had him add a page count to a number of views for every single article, and then we're writing it to the database every time somebody views a page. It's really simple. You say, that's probably your issue right there. We have a lot of readers. That's a problem. You say, well, I know how to fix this, Doug. When I was at DPC last time, there was this dashingly handsome fellow who told us how you could use Redis to count pages. If you were here yesterday, you probably saw it. So I'm not going to cover how you use Redis to do that again, but it's just incrementing an ID over and over again for every page count, and that's going to take the load off your database server here. But that gives us a little bit of problem. Some of our data is in Redis, and some of our data is in MySQL. And this has become a real problem because our intern, in his infinite majesty, has gone and changed our API all over the place. So now we need to move view counts out of the database into a faster system and not break everything along the way. So our controller looks like this. We have an article and we get a view count. When we're storing this in the database, this worked fine. Okay? But now it's in 100 places in our code. That's a real issue. So here's my proposed solution for you. All right? We're going to use column type integer here and remove it. The intern put it there, and now we're just going to have a simple property. All right? This is not mapped or persisted to the database in any way whatsoever now. All right? And we're going to write a listener. Surprise. All right? Now we're going to listen to the PostLoad event. Doctrine fires this PostLoad event every single time it rehydrates something from the database. Now, if you call new article, it's not going to be fired. Okay, so you probably want to set this to 0. You don't have any things when you instantiate the article for the first time, so it doesn't matter. But so every time you fetch it in the future, it's going to call this listener. And this listener is pretty simple. We're going to defeat Doug's request in one slide. All right, PostLoad. We're going to get a model from the entity. We're going to check if it's an article. All right. Now we're going to call out to Redis, and we're going to ask Redis for what the heck is the page count for this? What's the number of views for this page? I won't show it because you should have been here yesterday. It was magical. But you just have to say something like Redis get, page view, and then put the article ID on it. So it's like a one-liner. And then we're just going to do model set view count, current rate. Or, well, it should be, set view count, I'm sorry. That's it. Okay, now if we call this anywhere else in our application, This is going to work perfectly. We have basically bridged the gap between putting our data in two different data stores. Our API has not changed in the slightest. Pretty cool, huh? Now, if you want some really cool examples of what else you can do with PostLoad, the Doctrine cookbook has this great article about using it to implement strategy pattern. What you do is maybe in my article I require a certain type of calculator function for something, and I pass it in the constructor. But that's not persisted in the database. It's not going to be there when I come back. So you can create a protected property there that stores the name of the class for whatever your calculator was, and then rehydrate it on PostLoad. So it's like your calculator object never left. This is a really great tactic for things like value objects and stuff like that you want to do. Okay, so there's a lot of cool power here. The best example, I'm sorry.
A quick question.
Yeah.
The PostLoad is done after something is fetched from the database, right?
Yes, sir.
Okay, so if you do an update every time a page is loaded and data is fetched from the database, isn't it performance intensive as well?
You're going to be using the event to do it, but it's something that you would probably be doing anyways. So, I mean, you're fetching it from the database anyways. That's really your bottleneck, on every page load. Does that answer your question? Ask me afterwards. I'll understand better then. Okay. So the coolest example I've seen of this, honestly, is from Jonathan Wage. He's one of the guys at OpenSky. He's one of the main contributors to Doctrine. And he has a presentation where he uses this to bridge the gap between MySQL and MongoDB. At OpenSky, they have lots of different products, and he uses it to keep the products in the schemaless MongoDB database and the financial records in MySQL. What he does is instead of calling out to Redis or whatever, he plugs in a lazy loaded collection from the Doctrine MongoDB ODM and plugs it in there. So he has like associations like you do with Doctrine if it were all in MySQL, but you never see the difference from the outside. Your APIs are exactly the same. So you never know the difference if I'm dealing between MySQL data and MongoDB data. I would show this to you, but he's got great presentations about this on SlideShare, and I don't want to just steal his code. That would be wrong. So I'm telling you about it instead. All right. But it's a really, really cool technique, and this is something that I haven't seen implemented anywhere else. And I think this will be continuously important in the future as we probably work NoSQL into more and more places, nooks and crannies. You can use this to bridge the gap. All right? There's many, many uses for this PostLoad event. It's very cool stuff. Now, as we come toward the end here, I want to talk a little about class metadata. I've been alluding and hinting about it throughout the presentation. And there's some cool stuff that you can do with it. I pose to you a simple question. I map my entities in Doctrine with annotations, XML, YAML, whatever it may be. How does Doctrine know what to do with those? What does it do with them? All right? How do these end up? Where do they go? All right? Now, when Doctrine is loading the metadata for this stuff, it compiles all those things into a class metadata. All right? Actually, it could be class metadata info. One extends from the other, so it doesn't really make a lot of difference, actually, just so you know if you see it. But this is basically a repository for all information about our class, and you can do some really cool stuff with this. All right? You get the metadata, like I showed you earlier, by just calling get class metadata on your entity manager. And then you can do things like get the table name in a pragmatic function here. This is really cool if you're like writing your own SQL queries in Doctrine, because you don't know if it's going to be the standard article, or maybe somebody slapped an @tables annotation on there, and now it's articles, lowercase and plural. So this gives you a way to write SQL that's always going to be correct, no matter how you guys have got your stuff set up. This is going to be doubly important because Doctrine 2.3 is supposedly going to bring naming strategies. How many guys here like to use their databases all lowercase and underscore? Yeah, exactly. Okay, it's a religious thing. And it means that in Doctrine right now, because it likes camel cases, you have to slap lots of extra renaming mapping annotations on your database, on your models everywhere. In Doctrine 2.3, you'll be able to plug in the naming strategy and just have this done one way or the other for you automatically. But that's global per entity manager. So that means if you're plugging in third-party bundles, then you can end up in weird ways. So I would highly recommend that you use the class metadata to find your table names for when you're writing custom SQL stuff. All right? It's the right way to do things. But this is actually just the tip of the iceberg. There's a lot more we can do with class metadata. You can get a field mapping, say the title field. This is going to spit out a lot of information in an array for you. Some of this stuff is pretty cool. Like you can get the field name automatically, you can get the type, et cetera, et cetera. You can fit the length. If we said it was only 100 characters long, we can do that. All sorts of stuff. Now you might say, I don't want to crawl through an array. So there's a lot of helper functions in class metadata for you. You can get field names. This will let you, combine with the previous one, loop through and get the information for every single field. There's reflection class and property if you want to share those instead of instantiating your own all the time. There's get column names, so you can get the mapped column name for something. Yay, whoop-de-doo. Or you can get the type of the field. Title is a string, content is a text, stuff like that. It's important to note for a little later on in the talk here, to remember that the types in Doctrine are essentially semantic. Okay, they're not, tiny int 1 is Boolean, it's Boolean. Okay, so we can work at a higher level of abstraction there. I want to give you a simple example about how this can be useful because it seems a little weird right now. And by simple, I mean a Symfony example. All right, so in Symfony 2, this is how you build a form. All right, the long and the short of it here is that you just need to do, tell it I want to add title and I want to add content field. All right, and in my controller, I have an empty instance of article, and I bind that to my form. Okay, and if we output it, yay, we have a form. I did it. Congratulations to me. But there's something a little fishy here. I have a text input area here. That makes sense. I mean, that's a good default. But I didn't say shit about a text area. Where did that thing come from? How did it know to put a text area here? All right? There's nothing about text area. It's just its content. But yet, I have a text area. Now, if you look in the bowels of the Symfony Doctrine bridge, then you can find that this is exactly how it works. I'm simplified the code, but this is it. It takes the metadata here. It gets the type of the field on a particular property, title, content, whatever. And it says, hey, if it's a string, I'm going to guess it's probably a text input field. If it's a Boolean, I'm going to guess it's a checkbox. If it's an integer of some kind, I'm going to guess it's an integer field, with validations, etc. If it's text, well, hey, text area. And, of course, a default. Now, there's a whole lot more guesses in here and stuff like that. But you can use this to automate a lot of boilerplate code by using the information that you already provided Doctrine. All right? Cool, huh? So we write a lot less stuff. You can even take this a step further. One more thing. All right? Does anybody here get that reference? No. Darn. All right? Let's say we have a get association mapping. This is like get field mapping, but it works for relations. I can use this in order to get other information about other articles, about other entities. This comes with a lot more information. I can't even fit it all on the screen. But some of the ones I want to point out in particular are target entity. This is the actual class name of the opposing part of the other side of the relation, and type. Now, type 4 doesn't sound very useful, but this is actually set up to be based on a constant. But this tells you, is this a one-to-many, one-to-one, many-to-one, whatever it is. You can find that out automatically. Now, you can get a list of all association mappings in one go. These are pretty useful. They're helper functions that automatically tell you, should I expect a one-to-one relation, like in the sense of I've just automatically, a article has a user, so it's just one, or a collection function in the sense of, should I expect a collection of comments, for instance. So you don't have to worry about figuring out what the right constant is. You can also get the target class. So if I ask for what the target class is for comments, I'm going to get something like /demo/model/comments, okay? Now, if you know anything about Doctrine 2, like the find all functionality, you know that this is just a hop, skip, and a leap away from doing something much cooler, which is if I say I want comments here, I know what the comments are, I know what the class name is, I have the entity manager, so I can automatically hydrate this field right here. I didn't say anything about what class this should be. All I knew was the class name, and then I can say, hey, Doctrine, get repository for, comments, and find all. So that's how Symfony provides functionality like this, actually. It's pretty simple. Now, of course, you shouldn't base all of your code on using Doctrine metadata. I mean, who knows? We'll be using Doctrine 3 in 5 to 10 years, right? So, make this an extra feature on top to reduce the amount of boilerplating you have to do. All right? So that's it. Oh, yeah. You can set all this stuff. I mean, we've been reading so far from class metadata, but you can actually change it all on the fly as well. You can add lifecycle callbacks and things like that pragmatically, which is kind of cool. There's over 100 public functions on there. I cannot possibly go into all of them. There's a lot of cool stuff you can do with it. But here's my question: is there a good reason to modify it? There's a lot of good reasons to read from it, but about writing to it, my answer is probably unless you're writing a driver like the annotation driver, probably not. You can shoot yourself in the foot really easily here unless you're, say, a Doctrine core contributor. So don't do it. All right. If you insist on doing it for some reason, there's an event for that too. And you can just load class metadata, and then you'll get the class metadata there, and you can use things like, add lifecycle callback and things like that without having to specify annotations. All right, so where's the manatee in this case? Where's Doug? All right, you're the manatee in this case. Doug is not going to come up to tell you, hey, reduce the amount of boilerplate code you're writing. You have to know what you're going to do with this. And there's a lot of cool uses. Right now I'm working on a pull request for JMS serializer bundle. Does anybody here use that? Okay, my colleagues apparently. You have to specify decoding and encoding information to transfer this stuff from JSON, like tell it, hey, this is a string, or this is a Boolean, or this is an integer, so you can decode it correctly. But when you're setting this up in your models with annotations, then you have to specify it twice, basically, in just slightly different syntax. So now you can use the Doctrine metadata to basically figure out what it's probably going to be. All right? So that will take out a lot of boilerplating of the code there if you have to do it. All right, so finally I want to come to the end here real quick and talk about service layers. Now, normally we write code like this, model, controller, and view. But many days nowadays, it's a buzzwordy thing to add a service layer here in between. And the main reason I think that people add service layers is when they need to bundle functionality. I mean, you get to control your API, absolutely, and that's cool, but frequently your API ends up looking a lot like when you're working with models, or just more bulky. So I think the main reason people write service layers is to have things happen before or after other pieces. Like for instance, I add solr to my stack. I need to add a service layer so that every time I update a model, then I can update the solr stuff as well in one place. But I've shown you here that you can do that with many of the events in Doctrine. Does this mean stop building service layers? No, don't, because you're still going to need them for big enterprisey stuff. What I've shown you here, I think, are either implementation details for how to build a good service layer with minimal amount of code, or to build a stalling tactic. Because I'm all about 80% solutions. And most of the time, for most applications, I don't think you need a service layer. I really don't think you do. You just need it for those one or two cases where I need to, pass things off to external services or not. All right? You can use events to get around that, to buy yourself some time and not have to build a significant amount of overhead or copy and paste code into your application. So that's really it. All right? So service layer, consider it if you need it, but maybe this is an alternative for you, okay? Be smart, too. A lot of the event stuff I've shown you here today, don't use this as a substitute for writing clean code. Don't, add 3,000 event listeners to your code. That's not what I'm saying. If the number of event listeners you are adding, probably goes over, I don't know, this many fingers in a big application or so, you may want to start thinking about a service layer anyways. Okay? So be smart. Don't overdo it. Smart usually means simple. Keep it simple. Don't overuse this stuff or it will bite you. Lastly, you need to test when you're working with a lot of events like this. And when I say test, I mean test a lot. And when I say test a lot, I mean test a lot. Okay? Things can go wrong in weird ways and weird circumstances. There's about 9 different ways to do anything in Doctrine, and one of them may break your event stuff. So read the manual. When I started off with events, there were no documentation about it, and it was amazing to figure out every little piece, and also really painful. That's why my hair is going gray, right, from that one instance. So make sure that you read the manual and use it wisely. And if you get lost, ask for help. In the meantime, go forth and rock. Thank you for coming.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.